What are GPU-accelerated neural networks? What role does GPU play in AI development? What are AI chips? And what physics can bring to artificial intelligence research? Following is my conversation with Toby Young, a data science researcher, physicist by training, and head of data science at Brytlyt. Enjoy. Toby, could you describe us the concept of GPU-accelerated neural networks?
GPU-accelerated neural networks, sure. We start off with our neural network, which is a bunch of neurons that we can use to kind of train on data, how we learn, for example, feature recognition, learning where a cat is in a photo or some other animal, etc. And the standalone neural network will work just fine with your ordinary computer. Whereas the GPUs come in, the graphical processing units, and they can be used to accelerate the performance of the neural network. This is done purely by the architecture of the graphics processing unit itself. So we know that our normal CPUs, they can have 4, 8, 16 cores. It's quite common these days, and each of those cores can work on an independent part of the problem. What GPUs have and how they accelerate the learning of neural networks is they contain often thousands of cores. I know the latest GPUs that have come out in the latest years, they can have 10, 15,000 cores, and these can all do independent operations. So they can run and train up a neural network in parallel, which hugely speeds up the rate at which we can train neural networks for a specific task.
So this is why NVIDIA grew from a gaming company into an AI chip company, one can say.
Yes. I don't think they've abandoned gaming entirely.
No, they didn't.
No, they didn't. They'll keep on that. They've reopened the book of ray tracing to draw shadows and stuff like this on GPU. But yes, they have a bent, and it seems as though artificial intelligence and the trends in artificial intelligence are also somehow dictating the way that GPUs are being developed, the actual hardware that is under that. And what they're good at, what they're specifically good at, is doing very simple operations very, very quickly. And it's that part that is used in the neural networks. So from the graphical side, we know that we want to render these complex three-dimensional geometries on a screen. And they do that by drawing little triangles. These triangles match up to become the graphics that you see. And drawing these triangles is a repetitive, very simple operation that GPUs are very, very well accustomed to. And with the neural networks, it's a similar deal, that the additions and multiplications that go through a neural network while training are simple enough that the GPU can handle those in a massively parallel architecture. Yes.
In the context of GPU-accelerated neural networks, could you describe us what your company Brytlyt do?
Yes, so this comes into two parts. So our Brytlyt is built on GPUs as well. And we have a database that runs on GPUs. So all of the data that you would normally put into a spreadsheet, for instance, can be held residently in GPU memory, and it's there. And you can run searches and algorithms on that data to query it to get the results that you want. If you had a database of music, query artists and query similar sounding music, for instance. So we have that as the database. So the core data is already there on GPU. Why not add to that a neural network or a trainable neural network that will also run on GPU and will enable, you could train it and enable it to do inference on your data, find patterns in your data immediately on the GPUs. So what that does If your data is already on GPU, we don't have to worry about moving it to the model, training on the data, and then moving it back into the database. It's all stuck in one ecosystem, and you can bring the models into the database and run directly on the data to learn whatever patterns you have for it. That is what we're aiming to do at Brytlyt, to try and make that accessible as well to the end user. Yeah.
Where are your solutions applied? What kind of industries?
One recent one, quite exciting solution, is in a smart city where we have live data streaming in from the city, the position of taxis, the positions and motions of buses, trains, and all of this data can be taken into a database. And you can imagine in real time, that flow of data, there's a lot of it, and it needs to be processed very quickly. And there's a smart city that is using the GPU database to ingest all of this data and analyze it with pre-programmed analysis or with neural networks. This can be done, and to initialize alerts when, for instance, there is a traffic jam or an accident or some cause that is occurring. Mm-hmm.
My first association with smart cities is China, because they are building this enormous 5G architecture right now, 5G infrastructure. It's a better word. So I know that they have already some cities covered with very densely with 5G infrastructure already. So to have real smart cities, in fact, they have already a smart highway between the cities.
Oh, they've introduced this.
Yes, they do. So how far are we in Europe or in the Western world towards smart cities as of now?
Actually, I've seen in the UK the concept of smart motorways has been introduced, which can, again, this is all in real time. I would wonder if they're using GPUs in real time to follow traffic congestions and to direct traffic into the correct lane where they want to go.
So in China, it's already there.
It's already there in China. It's already there. So I guess Europe is catching up. There have been some interesting experiments in the USA on smart cities, but it seems as though we're lagging somewhat. I think there's a lot of apprehension on what can be done safely, of course, in these situations.
How much is AI development reliant on the progress of GPUs development or chip development in general?
I would say hugely. The biggest problem with training a neural network is they train like this. They start by looking at the data you have and trying to produce the result that you want. And it does this by doing random actions, by producing random responses to the system. And during the training process, you can slowly massage the neural network so it's in a state where it's providing the correct answers, is what we hope. That's what we're hoping for. And this process takes a very, very, very long time. Not really feasible using the standard CPUs, the traditional architecture, if you like. GPUs, as we said, these parallelize very, very well. And they can reduce a training session from days, weeks, down to a few hours. And this does a few things. One, not only is it just faster to train, because that's one very important aspect, but it enables the people who are training these artificial networks to run more experiments, to prototype things a lot more quickly, we can say. So GPUs, just having the speed there and the power and the control, is enabling people to prototype new neural networks, new types of neural networks, as well as to train very, very complex networks, such as this chat GPT has been very much in the news recently. And that
godlike chat GPT.
Sorry?
Godlike chat GPT.
Godlike chat GPT, yes. This that I think if you have the best GPUs that we have, and several of them in several computers, even though it takes about a month to train it up to be able to do what it does. It's, I would imagine doing that with traditional architecture would take years. It would be literally infeasible. It would not be a feasible plan.
Is this progress of GPUs development running as fast as the progress of large language models? Because this is an interesting question. If we can reach, GPT-5 or GPT-15 without radical progress in the GPU's development.
I don't think it would be possible. Actually, sometimes I wonder if AI is improving the development of the GPUs because people see new problems in language, especially in large language models, that they want to correct. And GPUs are being designed to handle those problems, or whether it's the other way around and that more accessible GPUs are a lot more accessible now than they were 10 years ago even. Whether that realization, the fact that GPUs are easy to get hold of and run, whether that is accelerating the AI, and I guess it's probably a bit of both. The two are now hand in hand. It's difficult to imagine neural networks without GPUs and vice versa.
Who is the producer of GPUs mostly? Because NVIDIA is a designer, isn't it? Is it also done by TSMC in Taiwan?
That I don't know. That I don't know. I know the three big players are NVIDIA, Intel, and AMD, of course. I think there's some relation also with ARM architecture, because having GPUs now in mobile devices is quite common, not just for rendering graphics, but also for running image recognition software. Some mobile software will be able to look at your photos and start recognizing faces in there and labeling them as, oh, this looked like a holiday, and it's a holiday with your friend Jane and Fred, and it will be able to categorize your photos for you.
The question was related to, to the geopolitical situation concerning Taiwan. If we had, for instance, Chinese invasion, which I seriously doubt, but if we had a series of naval skirmishes between Chinese and Taiwanese or US navies, would it impact, global production of GPUs? And then we don't need all these letters about halting AI development, because AI development would be halted for 2 years because of lack of chips.
Because of lack of chips and lack of actually having the physical hardware to use with that. I have no doubts that there would be some impact, yes. And it would not be a positive impact.
So what do you think as an AI researcher on the letter from, I don't know, 3-4 weeks ago signed off by Elon Musk, Yuval Noah Harari, and Steve Wozniak? So not only Elon Musk, who's known for publicity stunts, but also an intellectual like Yuval Noah Harari, about halting the progress of AI for 6 months. What's your take on that?
Referring to the open letter, yes, I think that now has 25,000 signatures, something in this ballpark.
All right.
So it's certainly gathering up, and there are some very respectable people, good research and so on, who have signed up for that. I find it personally quite baffling. I found the letter quite astonishing. The letter, as I understand it, is asking for a pause. Let's just stop for a second and think about what we're building, because it is a genuine concern and a good one. ChatGPT and other such like large language models can generate, as well as generating useful or finding useful knowledge for us, it can also, it has these generators in it, so it can generate text as well. It can generate paintings. And some of this can be put to bad use. So I saw this open letter as an idea of having a 6-month AI winter, where we'll just stop and think about what we're doing and where we're going. But there's no suggestion of what we should do during this 6 months. And I don't see any mention of any incentive for people to do that, whether it's a researcher excited about their techniques, their language model, or whether it's a pure business trying to build a new product. There's no incentive given to stop. And although I also agree that the concern is very real, fake information, false information, and having these social media in general already has this problem of too much false information around there. I forgot where I was going with that.
So my finding is that companies like OpenAI are declaring and pledging openness in all their public speaks and public announcements, whereas they are not transparent, in fact. And I'm not into conspiracy theories. I'm rather on the other side. I hate conspiracy theories, but after having watched the interview of Lex Fridman with Sam Altman of OpenAI, when Sam Altman said, it's now not about more data. It's about, all this little twist where we came from GPT-3 to GPT-4. So our engineers, just fine-tuned the algorithms somewhere here, somewhere there, little twists. So I think that the public should be let to know what the little twists,
yes,
as they call them, really are, because the little they are not, in my opinion. And instead of all the talk about regulating an AI, even at the global level, which is, let's say, which are voices in the media as of now, I think that the key players should be pressed into just discovering all the little twists to the public.
Yeah, and I think you've touched on a couple of interesting points there. One is the openness of it. I think that was the driving thing that you said there is I think neural networks tend to be black boxes from a scientific point of view. We're not really sure how they work or why they produce the results that they produce. This is largely unknown. But the methods that are used need to be open. And I think people need to be aware of how to use artificial intelligence, be it in their day-to-day lives, in a good way. And what it really means for artificial intelligence. We look at the word intelligent. There's probably in the definition words like knowledge and understanding, which these neural networks do not have.
I wouldn't call it reasoning.
Reasoning is yes.
I mean, I wouldn't call the algorithm can reason as of now.
Absolutely agree. Yes, that's right. They're almost blindly. It is an algorithm, and it's learned what it can and will produce the results that it produces, the responses, which probably should say that it produces. They are deterministic. Given exactly the same situation, exactly the same data, they will produce the same mistakes, the same successes. And it's the lack of reasoning, the lack of understanding of the data, which is there, and that's fine. But I think there needs to be a general awareness that that is the situation. It's an algorithm that's running. It's not inherently polite. It's not inherently creative. It just has these effects. And it can give us very positive feelings as well as some rather negative, scary I have heard ChatGPT being described as quite scary in its human abilities, or its human-like abilities, which is probably a misguided way of looking at it anyway, because as we said, it lacks understanding, it lacks the reasoning skills that humans do have.
Coming back to chips for a while. Uh, uh, what are AI chips? To me, AI chips are very much associated with let's say AI powered e-health, where we can install some really tiny chips, which use very little energy and which produce very little heat, so that they can be even implanted into human body, and help make very advanced cognitive twins of our body at the end of the day. But I know that the AI chips relates to the term relates to something much bigger. So how would you describe it, and then how would you define it, and tell us what these are?
Yes. One of the recent trends in AI chips is, we spoke about GPUs earlier, about accelerating the training and inference process that neural networks have. Then there are tensor processing units, which are architecturally and software is designed to do these calculations at the highest possible speed that they can. And that's good. But then there are more specific AI chips, and I think this is more recent and very, very specific, in which if we think of a neural network as something like a switch, a transistor, and it will switch on or switch off, and we have hundreds and thousands of these little switches that build up a neural network that can do something quite specific, normally image recognition, or I'm not thinking about ChatGPT, but with these so-called AI processing units, AIPUs, would be built specifically for a neural network architecture to solve specific problems. And there are a myriad of uses for these things. You could build a chip that has that could fit on a camera, for instance, to recognize cars, to, I don't know, to count cars, or to check for traffic congestion, stuff like this. Or the other way around, you could have these chips built into your car to recognize stop signs, speed restrictions, and so on and so forth. We mentioned about the body implants. I think a very good use of them would be in prosthetic limbs, because these chips, the artificial network, can build very cheaply with a very small chip, build a kind of awareness around a prosthetic limb, for instance, to help the user with awareness of being close to a wall, because they would have no...
Up to the level of consciousness.
Maybe not to that level, I think, but it would be able to supply some feedback to the user that I don't know, their arm is close to the wall, or they're something
Fantastic.
like that. Yes, I think that would be a nice use for it, or to regulate more complex actions like running with prosthetic limbs, things like this. Yes, I'm rather wary of implants. I'm not sure where that would be going, as far as having.
It sounds creepy, but on the other hand, to me, this sounds like a major breakthrough for curing some very rare diseases.
Mm-hmm.
And well, I'm not that much into medicine, but I think that there are some medicine is the more collecting of data uh, from the body might create a breakthrough. This is at least what my intuition tells me. And if we can, make some experiments on cognitive digital twins, which is, let's say, digital models of the body parts. Well, this make some health issues curable, which for now are not. I mean, this is I've read a very interesting book on application of AI into health. It's called Quantum Care. I don't remember exactly now the name of the author, but it's I strongly recommend it to everyone. It's a short book, but let's say gives you a really brilliant overview of what's happening. It's from this year. And yes, I said about cognitive digital twins, but there is a very good there's a new word I learned that there were, let's say, there was research in vivo in medicine, which means research done over a real human body, then in vitro, which is like in a glass instrument. And then we have now a third way of doing research in silico. So in silico means research done over exact, or the more exact, the better, model of a human organ, which if we have implants, we, in my imagination or by my knowledge, we can get to real-time medical research very quickly.
This would be a major advance in that, in medicine, doing that, and real-time responses as well from these. I spoke, this was a couple of years ago with Luxembourg Health, and the guy there that I spoke with was very interested in some diseases that cause shaking of hands. I think multiple sclerosis was one of these, and with presumably a chip with a neural network on it would be able to distinguish between a shaking arm and be able to correct the electrical impulses for it, and distinguish and help with that as a kind of healthcare package, but would still allow the freedom of movement of the arm for other things like writing a letter or using a keyboard and stuff like that. That's an interesting use of, or possible use of, chip implants that would have some form of AI on chip.
To me, the biggest revolution AI brings is healthcare.
Yes.
And I think that it's not as much covered and as all this, daily use cases like, generating artificial images of cats on surfing boards and the like.
Yes, and drawings. I think that one place where it has made an impact is in tumor discovery, and is also an example where image recognition is used, but the artificial intelligence, not only can it sift through these pictures of tumors very quickly, it can sift through them at various resolutions and pick out, okay, I found a tumor, but it looks benign, so it's not a problem. Or to find another tumor and raise an alert and say, this looks like it's an aggressive tumor and requires some help. So these things, and that is one very nice application of AI, the things that can help a medical doctor in sifting through all of these pictures and these data to reliably find a tumor that can obviously help the patient very much if it's found in advance.
And I think that GPU acceleration really matters in this kind of use cases from technical perspective, doesn't it?
Yes. Huge volumes of data, and where speed is is probably more important than accuracy. If we can sift through all that data and present to the medical doctor, okay, I've got 10 possible problems with, or 10 possible tumors that I found, the medical doctor can carefully look through each of these 10 pictures rather than looking through the original data, which can be tens or hundreds of pictures of tumors, in order to find one and to find the patterns among these images in order to be able to predict if a tumor is benign or is aggressive. Yeah.
Apart from being an AI researcher, you're a physicist.
Yes.
What physics can bring to understanding of AI?
The understanding of AI, there are quite a few parallels between physics and AI. In fact, one is they are both observational sciences. So physics is mapping reality, is mapping nature in terms of mathematics, in terms of numbers. And AI is doing exactly the same thing. It's finding patterns in pictures, finding patterns in data, and modeling those with a neural network. Apart from that, the actual math that goes into building a neural network is very similar to some of the maths, or vast majority of the mathematics. Differential equations, differential operators, matrices, vectors, these things appear in both worlds, regardless of what you're modeling. So those are some cases where physics and AI do overlap, yes.
I see quite a lot of physicists in AI ML community, actually. So that's why I ask everyone this question, because to me, yes, this is a kind of both disciplines are similar to what philosophy used to be,
Right.
a kind of science trying to describe the whole universe. In these both cases with strong mathematical workshop.
Yes. Yes. It's in the descriptions of it. Plus, there's I think I would bet that physicists who move into AI, as I have, as you said, would agree with this. Is you can view, to describe an atom or describe the motion of electrons, we build mathematical models, functions, and we then try to minimize the energy of that function and look at what we have and see what the response of the system would be. Neural networks, I view them as just another function that we're trying to minimize the error of in order to get from the inputs, the output, the response from that model that we're looking for. So I was going to say, I was based in theoretical physics, and that continually comes back to me, that thought process. It's a function. We want to minimize it.
Yes, so it's nicely put. Also, you put it very nicely, and it's also nicely put in one of Lex Friedman's episodes with a mathematician called Vladimir Vapnik, an older gentleman, and he says, all this is one big fuss, because this is, let's say, about finding a perfect function, so to say.
Yes.
So there's something into it. How would you encourage young physics or maths graduates to pursue a career in data science?
To pursue experiment. Both the sciences, the traditional sciences that we know, and neural networks that we build, machine learning, deep learning, they're all based on experimenting. And in the same way, I think the best way to get started is to build your intuition up. It's not so much worrying about the math. We can come to that later. I approach it from that side, but there's no reason to do it purely from the mathematical side of things, but to build an intuition of how these neural networks behave. There are plenty of open source neural network packages, software that can be put on your computer, and you can experiment with them, try some image recognition, sound recognition, speech to text, and building up that intuition as well as having the mathematical background is a very, very good way to start, to get learning by doing. That's the way to do it, I think.
Yeah, that sounds exciting.
And it is a lot of fun. The more intuition you can build up, the more fun it becomes, and the more the ideas come to you on how you can modify, extend, and use techniques in AI in order to achieve the responses from the models that you're looking for. It does become a lot of fun. It's an experimental science.
Last question. You pursued your career originally in the academia, but what can business learn from academia and the other way around? The question I'm asking.
What can business learn from academia and the other way around? One thing that happens in academia, and it is nice that this can happen, is you have the freedom to ask the question why, much more than in a business surroundings. You can ask, why does that work? And quite often that question is not seen as being particularly meaningful in a business environment. It doesn't produce a product directly. It doesn't have a good engineering foundation, asking why does that work? Why does that happen? But what it does do is it goes back, yes, as we said, philosophy is attached to it. It enables you to assess your own knowledge and to be able to build on that. And I think although the aims of business and academia may be somewhat different, they're not completely different. But asking the question why in academia asking the question why in business a bit more, even if the question may not seem meaningful, would be a very positive thing to add to a business. And I think from the exact opposite occurs for academia, because you can get lost in asking why too much and following the rabbit down the hole. Academia, I think, could do with a bit more structure, which is not lacking in business. In the private sector, there are well-defined structures and how things are planned out and how knowledge will be carried forward. In academia, it's a bit more personal. It's a little more, of asking the why questions, and
unstructured.
A little more unstructured, yes. And both those things have their positive points, but if they could be normalized somewhat between academia and business, I think that would do both great credit. Yeah.
Toby, thank you so much for this conversation. There was a great overview, very informative about how chips influence AI development, and let's say how much depends on chips and not only algorithms. I think that we are not aware of this, say, en masse. So it was great. It was
thank
great
you very much
to
for
hear
having
about
me.
it.
Yeah, I've enjoyed the talk. I've enjoyed our chat.
And I hope this is, and also it's always a pleasure to listen to an academia person, intellectual, let's say, of what is happening right now in these topics, which probably have influence on us all.
Thank you very much. Yeah.
Thank you very much, and hope to have you again.
Thank you so much for listening to Sherpa Search on Tech. If you have enjoyed the show, please subscribe to our show wherever you listen. Thanks again. The Sherpa Search on Tech podcast is a production of Sherpa Search, an executive search firm specializing in the tech industry, helping hire the right people for expert and managerial positions, and advising how to build and develop long-lasting, high-performing IT teams. If you would like to learn more, reach out to us at maciej.szczerba@sherpasearch.tech or visit our website sherpasearch.tech. See you next time.